Hello and welcome to o'kellychemistry.com. I'm Ivana O'Kelly and thanks for joining me. In this video, I'm going to talk you through how to do empirical formula calculations and molecular formula calculations. Grab your pen and paper, periodic table, and a calculator. Let's get started. So I thought we'd start with comparing what is the difference between empirical versus molecular. So our empirical is going to represent the simplest whole number ratio of the atoms that are present in a molecule. And listed here are our steps that we need to follow. So step number 1 is percent to grams. Step number 2 is grams to moles. Step number 3 is you're going to then divide by the smallest mole. And the last step is multiply till whole. Now sometimes you don't necessarily have to do this last step, but I will have an example for you. Our molecular formula is going to be the actual formula of the compound. And in order for us to figure out the molecular formula, we need to calculate the molar mass of our empirical. Then we're going to divide the mass of the actual formula by the mass of the empirical formula. And then that will give us a ratio, and we'll multiply each of the subscripts in our empirical formula by this number. So I mentioned that we don't always necessarily have to go to the last step. So what I've done is I've made a little chart here, and if you have a decimal as a mole once you've done your division, if you end up with 0.25, you're going to multiply by 4. If you end up with somewhere close to 0.5, you're going to have to multiply by 2. 0.33 and 0.67 are both multiplied by 3, and 0.75 you're going to multiply by 4. So here I have a compound that we're going to go ahead and determine, is this an empirical formula or is this a molecular formula? So we're going to count up the number of atoms of each element present, starting with our carbons. So we see that we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 carbons. Our hydrogens, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Our oxygens, easily we can see that we have 2, and our nitrogens, 1, 2, 3, and 4. So we have 4 nitrogens. So our formula is going to be C8H10 O2N4. Now, let's take a moment and look at this formula and ask ourselves, can we break this down into something smaller? And yes, we can. We can divide each of our subscripts by 2. Therefore, we will end up with C4H5ON2. So because we were able to divide it down into its simplest whole ratio, this is going to represent our empirical formula. And this will be our molecular formula. You're probably wondering, what is the name of this compound? Well, the name of this compound is caffeine. So that's our segue into our calculation this evening. So our question reads, determine the empirical formula of caffeine if it has 49.98% carbon, 5.19% hydrogen, and 16.48% oxygen, and lastly 28.85% nitrogen. Now I've gone ahead and created a table. So step 1 is percent to grams, step 2 is grams to moles dividing by our molar mass, and step 3 is we're going to divide by our smallest mole. So in first step is very easy. We're taking the number that's given in the question and we're switching it out from percent to grams. Our second step, we're dividing by the molar mass of that particular element, giving us our number of moles. Then we're going to look and see which one of these is our smallest mole, and that's going to be our 1.03. And our last step here is we're dividing each number of moles by the 1.03, and that's going to give us our number of atoms of each element present. So we have C4 H5ON2. So that's going to be our empirical formula for caffeine. Now, the next part is determine the molecular formula for caffeine if it has a molar mass of 194.19 grams per mole. So can you remember the steps? Our first step is we're going to calculate the molar mass of our empirical formula. And we'll do that by multiplying our molar masses by the number of atoms present, giving us 97.11 grams per mole. Step 2 is we're going to divide the actual mass given in the question. So we'll be taking our 194.19, dividing it by what we just calculated for our molar mass of our empirical formula, and we see that we get 2. And then our last step is we're multiplying our subscripts in our empirical formula by this number. So that's going to give us C8H10O2N4. So this will be our molecular formula for caffeine. Here's another question. I have 250 grams of a compound are found to contain 66.5 grams of potassium. Remember, potassium is K. And 88.25 grams of chromium. Chromium is Cr. And the rest is oxygen. The question is asking us what is the empirical formula for the compound. So again, I've listed my elements here. My step 1 is I'm determining the number of moles. My next step is I am dividing by the smallest number of moles. And then I see that I have 3.52. So I have to draw on my knowledge of what do I do if I have a decimal, because we can't have half a mole. So in our last step, we're going to have to multiply by 2. So we'll end up, our potassium will be K2, our chromium will be Cr2, and our oxygen will be 7. So our formula, let's write it up here, will be K2Cr2O7. So that is our empirical formula for this compound. Next, what is the empirical formula for a compound that contains only carbon and hydrogen if it contains 84.2% carbon? So for our carbon, we'll write down our grams. We'll take our 84.2% and we'll make that into grams, dividing by our 12.01, which is our molar mass. And for hydrogen, we're taking the 84.2 away from 100, and that will leave us with 15.8. We're dividing that by the molar mass, which gives us 15.67 moles. We're then going to divide by our smallest mole, which are 7.01. And then we're going to have to multiply everything by 4. So we're timesing everything by 4. So we will have 1 times 4, which is C4. And our hydrogen, 2.23, multiply that by 4 is going to give us 9. So our formula will be C4H9. So ladies and gents, I hope that was able to help you with a couple of examples for empirical formula and molecular formula. If you like this video, go ahead, like and subscribe, and I look forward to seeing you at the next one.